All right, so this is a formula. It's a special kind of formula called a recursive formula. And I'm going to teach you about these formulas right now. What this really means, this complicated looking thing, is that I would get this result. 10, 18, 26. Let's see what's going on here. Just adding 8 each time. Okay. So why does it have to be this complicated to explain? You start with 10 and you add 8 each time. That's really what it means, though. All right, so let's go to some other formula, and right out in the middle of it, like, I don't know, like 20 or 30 terms in, let's say it does this. 208 and 210. Oops. Da-da-da. Okay. Do you get that? I don't know what term those are. That's not, maybe it's the 20th term, maybe it's the 22nd. I don't know which term it is. If I'm going to say I don't know which term it is, and they have to be U's, like U sub something. U sub 1 would have been the very first one. If I'm going to guess it's the 22nd term, that's kind of dangerous because it might not be. So what do you think I should put for it if I don't know which term it is? N. U sub N. Do you get that? That's a lot like if I have X and I have Y for a couple different, X is like 6 and Y is like 8. You can call those U sub 1 and U sub 2. You could call them any letter, but I'm going to choose U's this time. U sub 1, U sub 2. It's just a different way to do variables. That way I don't have to pick different letters all the time. Instead of picking A, B, C, D, E, F, G, I can pick just one letter, U, but then the number on the bottom tells me which one it is. That's the first variable, that's the second. All right, so if I'm picking this random one, I don't know what it is, so I'm going to call it U sub N. What's the one right after it going to be? Yes, U sub N plus 1. And how about the term right in front of it? Whatever number's right here that I can't see, U sub N minus 1. Yes. Now let's go back to that formula I gave in the first place, right here. No, wait, that's not the formula I gave you. Where's the one I gave you? Is that the one I gave you? Okay, good. So, what's the first term? Do you get how U sub 1 equals 10? It's telling me that the first term in my sequence of numbers is 10. And then what does this mean? Any random term is given by, what's that mean? The term right in front of it plus 8. So it's that any random term, you take the term in front of it and you add 8. See, I'm trying to speak in the language of the computer. Because we're going to tell the calculator this, and then it's going to be, oh, okay, I know what you want. And then you'll be able to say, I want the 400th term, and it'll be like, oh, so it's this. Calculate. All right. And then this last part is just a little annoying domain, and it's trying to tell you that the n's are only going to work for the second term on. This formula right here will only work starting after the second term, because it can't tell you what term was in front of the 10, because the 10 was the very first thing. Sort of like this, we're still arguing about how the Earth started. So the Big Bang Theory is a theory. The Christians believe that it was created. There's other religions that believe it's created in different ways. Anyway, the point is, we're still arguing about the very beginning, because we really don't know. We're here right now. But where we came from, how this all started, is still up for debate. Well, that's like this. We're here. Or you could even argue maybe we're a little farther down the road. But we don't know what was before this 10. Could you say it was probably 10 minus 8? And say it was 2? Yeah, but you don't know that. Don't know that for sure, because you can't see it. All right, so if you take this formula right here and say, I know I start at 10, I know I'm going up each time, and I'm saying that the numbers have to be at least 2. 2 is the only term where I can actually use this formula. And then it has 2. 2n, the number's bigger than 2. All right, so let me give you another one. U sub 1 equals 5. U sub n equals U sub n minus 1 plus 5. n is greater than or equal to 2, because basically it's always one number bigger than that, because that's the very first term. So this formula will only work on the second term, is what that means. You don't really even use it. You don't have to type it in the calculator. We don't use it very much, but it's something you have to have when you actually write them out. This little domain. Okay. What did I just give you? I gave you a list of numbers. I want you to make the list of numbers. 3 of them, first 3. That's all I want to know. And if you get the first 3 numbers, write them down. Zoom in on it and billboard it to me so I can see that you're getting it. Okay. Come on, hurry up. Don't turn and look at other people's answers. Just look at your own answer. Give your best guess. All right. You started with 0. Good. Good. All right. Don't start with 0. What's the very first term? See, it says 5, so I start with 5. I had several people start with 0. 5 is the first term, because it says so, right here. And then after that, what's the next term? It's add in the next term. There's the first 3 terms. All right, and you could go the other way. This is a little harder now. 12, 24, 36, write me the formula. I'll give you a hint. It always starts with the U sub 1. How many of you knew to start with U sub 1 equals 12? All right, good. The next line is the hard one that I'm kind of afraid to ask to see, because I'm afraid a lot of you will mess it up. But who's confident? 2 people. Give me what you think it is. You are correct, because it's adding 12 each time. Will the number you add have to be the same as the number you started with? No, I just did 2 examples like that. Don't feel like you always have to start with like a 5 and then you're always going to add 5. This tells you what to add right here. All right, nice job. And there's one more thing that it says, kind of an annoying little thing we got to add on and try not to forget. What's that? It's called the domain, and it's n is greater than or equal to 2. Always one bigger than that. Why do I keep saying that? Why don't I just say 2? Because sometimes we'll change this to be a different starting term. For right now, we're going to start with 1. And we'll do that all day today, but eventually you'll learn that in real world problems where you're doing like investments and things with time, it's better to actually start with UCC. We're not going to do that today. All right. Yeah. And at this given moment is time 0, and then after that is 1 minute from now, 2 minutes from now. Okay. Would you please try to make this one for me? Perfect equation for that. It's called the recursive equation. I'm using a recursive notation. This is, believe it or not, something that is on the test that you have to pass to graduate from the state of Minnesota. So we're learning something today that we actually probably would have thrown it out by now, because there's other ways you can do these functions that are a little easier, but this recursive notation is on state standards. You got to know it. So, and honestly, it just kind of makes you look way smarter than you really are. You know, show your parents this one and then say, well, of course then, Mom, U sub 1 must be 8, and U sub n will be given by U sub n minus 1 when I subtract 3. And of course the domain has to be n is greater than or equal to 2. Makes you look way smarter than you really are. Did I do that right? Raise your hand if you had the same thing as me. Okay, good. All right. Sometimes they give you the numbers and you have to write the equation. Sometimes you give you the equation and you have to give them the numbers. Let's do another one where they give you the equation. U sub 1 equals 12. U sub n to the to u sub n minus 1 minus 2, or n is greater than or equal to 2. Tell me what the fourth term is. You don't have to write the whole equation down. Just write down the four terms and then underline the fourth one. Circle it or something. Sure, but it's probably easiest to write them all out. If you get... I'm subtracting 2. 10, subtract 2, 8, subtract 2, 6. Raise your hand if you said it is 6. Okay, good. Now, you've learned the basics of this, so how do we apply it in real life? There's a couple examples I want to make sure you understand. One would be if you're checking for like defects, for instance. Wouldn't it be nice if when they found out, of course there's defects in iPhones, for instance, or iPads. Wouldn't it be nice if like every 100th iPad was the one that was messed up? Wouldn't it make it so much easier? Think it happens that way in the real world? No. Okay, so let's say that they checked and there was a slight flaw and they number all the iPads. Okay. Actually, I'm going to not use iPads. I'm going to use bowls. I had this guy make bowls down on the island of St. John, and he's really good at it. He bought this really expensive lathe which helps turn bowls, and then he gets this really high quality wood. I had no idea wood was worth so much money. He showed me a little stump of a special kind of wood called Lingenweide wood, and this wood is it can last. Well, they found samples of it from 800 years old, and it hasn't rotted or anything. So like when people would build stuff out of this Lingenweide wood, it would last like 800 years and not rot, and even out in the elements and stuff. It's insanely hard wood. And he showed me this little stump of wood. It was worth $400. It was probably just a little bit bigger than this chair. A stump like that piece was $400 just for that chunk of wood. So if you got one of those trees growing in your backyard, you'd probably pay for your college education right there. They grow really slow. You probably don't have one here in Minnesota. All right, so he turns these bowls, and he's numbered every single one of them. It's kind of cool. You look in the bottom of the bowl, and it's got a number, and you know it was his like 507th bowl or whatever. Okay, so let's say that there's a flaw in these bowls. And bowl number 33, and bowl number 62, and bowl number 99. Do you get kind of the pattern I'm trying to do here? It's not quite 30. What's closer approximation than every 30 bowls? Okay. Would you agree that that one was 33 from the very first bowl? And then if I had gone to, what would be the next one if I had gone by 33s? It would be 66 there. And what would this one be? 99. And so therefore, doesn't it look like it's about every 33 bowls? Do you get that even though there's this one, this wasn't really 66 like it should be, it's about every 33 bowls, so we can estimate about 33. I'm going to put like about equal to there. So it's about every 33 bowls. So sometimes you have to make adjustments like that to the problems because it won't be clean and it won't be like, well, yeah, you add 33 every time. Well, sometimes it'll be like add 33, other times it'll be like add 30 or 28, and then the next time it's add even more to average out to like 33. Okay, write me the equation for that one. How's it start? Usable? Did I number anything before 33? Nope, so u sub 1 is 33. Don't get confused by thinking you know that he started with a bowl number 0. Maybe, quirk, he decided to start numbering his bowls at 33 because it's his favorite number or something weird like that. Or maybe his very first bowl was actually bowl 0. Look how that would really kind of mess it up. Because then after that, his second bowl would actually be bowl number 3, or 2, or no, or 1. Yeah, if his first bowl was bowl 0, the second bowl would be bowl 1. Get how that would mess it up? That's exactly what you're going to have to deal with when we change u sub 1 to being u sub 0. It's going to mess with your head. So for right now, we'll just stick with the first bowl is always u sub 1. All right, u sub 1 is 33. And then u sub n equals u sub n minus 1 is the thing you always say next. In case you're not clear on what I'm saying here, it's u sub n. Sub is in subscript. U sub n minus 1. All right. And then, what do I do each time? Add 33. And then, you got this little annoying n is greater than or equal to 2. How many of you remembered that? Yeah. Easy to forget. All right, there's your formula. And next time, sometimes they're going to ask you to tell them like the 400th term. What on earth are you going to do? Are you going to actually want to add the number 400 times to find out the answer? No. So there is a cool way on the calculator to do this. So we're going to go back to a simple one. U sub 1 equals, let's say 3. U sub n equals u sub n minus 1 plus, let's add 7 each time. Okay, we know that the first term is going to be 3, next term is going to be 10, etc. How do I get this in the calculator? The domain part the calculator doesn't even need, so I'm not going to put that up there right now. Grab your graphing calculator. Let me show you how to put this in. The reason I'm teaching you this today, and I think some teachers are probably not teaching it today, you don't need it for today's lesson, but it's one of those things where if you do these by hand, and then you're told later that there was a way you could have done it on the calculator, isn't it kind of annoying? You want to know like how you could have done it. So I'm going to tell you right off the bat. See how this works. Some of you will use it. Some of you will just do them by hand because you don't want to mess with a calculator. But later in the unit, you'll have to use a calculator because it can get so hard. You won't be able to do it any other way. All right, so here is your calculator. Look, it's really complicated, isn't it? All right, let's get it into the right mode. Everybody hit mode. And you see how mine on the 4th row down says SEQ? You need to get yours into that 4th row down. There's function, there's parabolic, there's polar, and then there's sequence mode. We want to be in sequence mode. Now, once you get it, you move down to that, and then you go over here and you hit enter when you're on it, and you're on sequence mode. Okay, once you're in there, then quit out of it, go second quit. It's right above mode, second mode. Just quit. And you're quitting out, and then you're going to hit clear, just to now you have a nice blank screen. So you're out now. Got it set in sequence mode. All right, now here's how you do it. Everybody hit y equals once. Look at the stuff that comes up. The y equals isn't a bunch of y's anymore, is it? All right, so on the top row here, it says UN min. Hold on a second. Okay, I'm back from the pause there. So on this, the top row is always a 1. And remember how I said we were always going to start with u sub 1? Let it be a 1. If yours is a 0, change it to a 1. All right, next row down. I'm going to clear this out, even though it's painful because I'll have to retype it. I'm going to clear that out. And you see how it says u parentheses n? Guess what the calculator is trying to say? U sub n. SUV. U sub n. Except it can't do subscripts, and so it uses parentheses for subscripts. Anytime it wants to do a subscript, it has it in parentheses. So u sub n is equal to, what do we always say? U sub n minus 1. Very good. So we got to get a u in there, and it's the one above the 7. It's the lowercase u. If you use the uppercase u, it messes everything up. See right above the 7, there's a little blue u. So you go second, 7, right above the 7. U. Now sub is parentheses. And the n is right on the x key. Right here. I'll leave it in red there so you can see where the n is. That's where the n is. Okay. U sub n. And minus is just what you think right above the plus sign. There's a minus sign. N minus 1. And you don't even have to put n parentheses, but I like to because it cleans it up. U sub n minus 1. Actually, you might have to in this mode. There's a different mode in the calculator where you don't have to n do parentheses. I'll show you that later. Okay, u sub n minus 1. And then what are we doing each time on this problem? On this problem, we're adding 7. Okay, it's this part right here. All right. So if we're going to add 7, then I go plus 7. Plus 7. What's my starting thing? My starting term was 3. I hit a 3 and I hit enter. It automatically puts it in those little brackety things. Now yours might not put in the brackety things. It all depends on which operating system you have in your calculator. Okay. You see how I got the thing in here now? The next line says V sub n. That's if you had 2 you wanted to enter at the same time. That's where you put the other one. Kind of like, you know how on the other calculator screen it says y sub 1 equals this and y sub 2 equals that. You could put in multiple equations. Well, you could put in multiple equations here. You could use V's or W's for other of these series and sequence problems. Okay, so we only need one though. So we got it in there. So now what's good now? Quit out again. Go above mode and quit. Get to a blank screen. Let's say I want the... Well, what's a term we'd be able to do in our head? Let's say the second term. Because the first term is 3. It's pretty obvious. Did you get that the second term is 10? Can you tell it u sub 10? With a 7. U sub... Sorry, it's the second term. U sub 2. U sub 2. And I hit enter. And it knows it's 10. And the nice part about that is I can figure out what the 400th term is. U is right above the 7. U sub, let's say the 100th term. And hit enter. And there it is. 696 would be the 100th term. You see how that could be handy? If they will ask you for a big number of terms later. Now, here's something that's really important. You know how it's kind of a pain to type that whole formula in? The cool part is, now I only have to change the part that I care about. Like, let's say they say, now we're going to have the problem start at 12. Notice this top number doesn't change at all. If it's starting at 12, that's the third thing down. That's a 12 right there. And then let's say that they're going to add 9 each time. Don't go delete all of this. Just move to the 7 and right over the top of it. Put in a 9. It'll be way faster once you've got it in there the first time. Then, if I start with 12 and I go up by 9s, second quit. Everybody figure out for that one, what's the 10th term? U sub 10. And one last little shortcut I was telling you before about you don't have to have an end parentheses. This is that part. Kind of weird, but they don't need an end parentheses. So U sub 10, I don't even have to hit that end parentheses. I just hit enter, and it's 93. Raise your hand if you got that one right. Good. Okay, you now know how to put these in the calculator. So when they ask for the 12th term, you won't have to do it out 12 times like other kids. Because to me, adding something 12 times really doesn't make you that much smarter. So I'd rather just show you how to do the calculator right up front. All right. So now, let's actually start your homework together. If you look at Schoology, you will find where your homework is. And let's see if I can pull up. There it is. And the homework is that for today, which is yes, the due date is the February 20th, but it says assigned on 2/19. All right, so that top one, arithmetic sequences. And here we go. Now, first few problems on this are just painfully easy. Write the first 4 terms of the sequence. Do you really have to type it in the calculator to do this? No, they're so easy. What's the first term? 20. What's the second term? Oh, look at this. It's adding 6 each time. All right. That's the next term after that. 32, and then add 6 again. 38. No need to use the calculator for these. So they're so simple. You're just adding 6 each time. Okay, so let's skip down. The first 3 are pretty easy, so let's go on. Look at number 4. Write a recursive formula to generate an arithmetic sequence with a first term 6 and a common difference. What does it say? Difference of 3.2. That means that it's going up by 3.2 each time. Common difference is what it's supposed to say. All right. Recursive formula, 10th term. This is where the calculator is going to be used. All right, so what's the formula? Remember how we always start? U1 equals, that's the first term. What's the first term? 6. U1 equals 6. Un equals Un minus 1. And then it's going up by what, 3.2 each time? Plus 3.2. That's how you write the little equation for it. Yes, we should have that little n is greater than or equal to 2. It's an annoying little domain that we should put in there. It basically means that this formula only works starting on the second term. Because you need, the very first term you can't see what's in front of. Okay, and then they want the 10th term. If I were you, I'd type this in the calculator, put in the 6 there on the third line of it, and then I would change what you add each time to add 3.2 each time, and then I do U sub 10. All right, just a reminder how to put that in the calculator. It's U sub 1 equals 6. You go to the, in here, goes on the y equals button. And if I'm going to start with 6 instead of 12, I put 6 right. Then, what am I adding each time? Go to the end of this line. If you already typed it in with me before, it'll be easy. Now we're adding 3.2 each time. Should look like that. And then all I got to do is quit out of this. You go to second mode, which gets you to the quit. And then you can say U sub 10. It's sub on a calculator, for instance. So U parentheses 10. So go to 7. 10. Now this is one of those things where once you get lost, it can be like, oh, I don't even know what you're talking about anymore. Come on up and I'll show you how to do it one-on-one if you want. Okay? That's the basics. Now, when it gets into the harder stuff, basically what gets hard about it is they give it to you in a graph. Well, what's the first term? Do you get that this spot right here and here is my first term? And do you get that it's a 1 down here and it's a 5 here? Just look at the numbering on the scales. So what they're really telling you is U sub 1 is equal to 5. And then U sub 2 would be this one. Would be here, which would be, if you're counting by 5, so it's not too hard to get there, okay? So they really gave you a list of numbers. They gave you 5, 10, 15, and 20. By giving you that graph, they gave you a list of numbers like this. And now you should know, oh, well, this first number, U sub 1 is 5. And U sub n is equal to U sub n minus 1 is how you always start. And I'll let you finish. Yes. All right. We are done with the video.